I'm Andrew. This is Adam. This is Matt. For real. No. So, yeah, so I work on the JavaScript team here at Wayfair on Storefront. Adam.
I work on the kind of core full stack team, also on Storefront.
And just a bit about Wayfair if you're not familiar. It's kind of the general slide to get you up to speed. Wayfair.com, a huge e-commerce company for furniture and home goods, based here in Boston. We've been an e-commerce company since 2002. Not the name Wayfair, but the company. And we have several large websites. Wayfair.com is obviously our largest, but we have a few other kind of sister sites, Just and Main, All Modern, our international sites, our mobile sites. And while we use a lot of different technologies, from the storefront perspective, we're a PHP backend. So all our customer-facing storefront pages are almost entirely PHP-based. We have a custom e-commerce platform, and as we'll discuss a little bit today, our MVC system that we've written over the years, as well as a lot of custom JavaScript modules. This is 2,000 plus. I think we're closer to probably to 3,000 now, for both our customer-facing and internal tools. We're going to talk about UI rendering today and UI rendering performance. And this is an interesting topic for a web performance meetup, because for web performance there are so many different pieces, so many different aspects of performance that you look at. Adam and I wanted to talk specifically about the rendering piece of it. You know, what is it that we do to take the representation of our pages, the data, the code that's used to describe what our pages should look like, and bring it to the user. Turn that into something visual that the user can see and interact with on the page. And so, kind of from a high level, from a technology standpoint, we have sort of two big pieces here, the server and the client. So we'll be sort of going back and forth between server and client performance and talking about sort of the interaction there. But when we talk about server performance, when we talk about server rendering, we're talking about the server building up the HTML for the views, what is supposed to be on the page, and then flushing that to the browser so that the browser can interpret and display it to the user. They'll also be talking about client rendering, and this is rendering within the browser. This is updating things in the browser as after the page has initially loaded. So once the HTML is on the page, the user does something to interact with the page, and part of the page changes. It might go back to the server, it might get more data from the server, it might request what new JavaScript modules or styles that need to be pulled down, but it's going to happen all in the browser, or start from the browser. This doesn't just happen once, so whenever the user requests a page on our site, they're going to get a new page back. So this process is going to repeat throughout the life cycle of a user being on our site. And that's also going to be the case on the client, on the browser. And some of these will repeat more than others. As our pages become more and more interactive, for example, client-side rendering ends up being more and more a part of that process. And so that happens over and over again during the life cycle of the page. In fact, if you look at our mobile website, you'll find that you only get one server-side page initially rendered, and then for the rest of the life cycle of the user's visits, it's likely that the browser will never, reload completely from the server. That'll be all client rendering from there on out. And so that's rendering. Sort of the subtitle of this talk was performance at scale. And we're kind of working on that title for a little while, and what does that really mean? And as we talk about it more and more, this comes up in our day-to-day talks too on performance, is that, in general when we think about code or at first pass, right, faster code is code that's written at a lower level. So we can tend to always write faster code, or code that produces a faster experience when we write lower level code. And then the inverse is also the case, that as we add more abstractions and more layers to our code, that it becomes less performant. And that's sort of the general kind of principle that we started with. And so, a lot of that means we have to balance things. It's not always just about being as fast as possible. It's also being fast, but being able to build features, being able to scale to a large team. So when we talk about scale, we're really talking about scale of architecture, scale of design, scale of being able to develop a large website with a large team. All right, so where did we start? Several years ago, we've been around since 2002, so things changed a lot over time, but say 4 years ago, 4 or 5 years ago, where were we? From the client side of things, we were generally using jQuery and other DOM manipulation libraries to update things in the client, so that was handling our client-side rendering. And from the server side, we were generally serving HTML straight from our PHP scripts. This was an issue. On both the PHP and client side of things, we ended up with a lot of problems as we tried to grow applications. There were global conflicts within the application. We had multiple modules being written by multiple teams that were either doing the same thing or manipulating the same piece of DOM that another team needed to work with, or another application needed to work with. We weren't able to really create components that could be reused throughout the site, throughout the application in a scalable way. And it turns out, even though some of this was fairly low-level code, jQuery and other DOM manipulation libraries can be fairly low-level. You're manipulating the DOM itself in the browser. It was also a problem for performance. Sort of went against that original assumption, but it turns out that lack of a solid abstraction for building out the UI meant that it was inherently risky to add new features. Because the developer didn't know, for sure what the fastest way to create something was. You had to have a lot of low-level knowledge to be able to create highly performant components. You had to have an understanding of how the DOM worked and what the fastest way to write a JavaScript function was. And so that was very challenging to be able to build performance as we scaled out teams. So the next step of things is where do we start looking towards adding some abstraction to the system, making it easier than just writing jQuery or HTML straight in our PHP.
So on the server side, one of the first things that we did was actually a transition from kind of very imperative style programming to using an MVC framework. And the big reason that we got into this initially was because we realized, like so many companies have, that a lot of our traffic and more of our traffic is coming from mobile clients. And what we wanted to avoid as much as possible is creating two entirely different websites that offer the same functionality. So this is something that the MVC pattern is great at because you have some degree of separation of concerns. You can have controllers that handle requests, get data from models, filter it through views. You can have different views for mobile clients and desktop clients. A step beyond that we took was we eventually found out that there's actually a fair amount of logic inherent to presentation that was getting needlessly wedged into our controller. So we ended up creating a separate layer, something we called view classes, that, it's not really a controller action, it's more like view-specific logic that you want to keep out of the actual markup, which is what was really happening otherwise.
So on the client side of things, we also made some improvements, or tried to. One of the big ones was implementing a library called Backbone. How many have heard of Backbone? All right, so awesome, cool. So Backbone is one of those JavaScript MVC style of frameworks. But Backbone is one of the kind of lighter weight ones. So Backbone really provides some structure for building out kind of an MV style application. And kind of a common quote you hear, this one's from Thomas Boyd, but Backbone is an unopinionated framework. And that's true to some extent. I think what we found is really an unimplemented framework. A lot of the pieces that you'd expect in a framework, and in fact a lot of the pieces of a framework that Backbone stubs out for you, are just that, they're stubbed out. There are a lot of functions that are just implemented as no-ops, and it's sort of expected that you implement them yourself. Which is cool, it's flexible, and you can kind of build something around it, but there isn't a lot there. And so this is what we decided to go with. It was fairly easy to start implementing. Backbone's about 1,000 lines of code. You can sit down and read it in an hour. So it's pretty easy to understand what's going on. It's not like super black boxed. It gives us the views and models that we wanted, so we could start getting away from that spaghetti jQuery code that we had. But DOM updates were still done with jQuery under the hood. So even though we started to give our developers some abstraction, there was still a lot of DOM manipulation that had to happen under the hood, and it didn't really scale out to exactly to the point we needed. So on the client side, we saw a lot of problems here. The JavaScript still had to read from the DOM at certain places to figure out the state, and part of this was just the nature of not having Backbone everywhere. And I suppose maybe if it was a greenfield application, that would have been different. But it was something that adding to an existing application became challenging. We're still doing DOM manipulations when the page was loading. So there really wasn't that cohesion that we needed between the server and client. So JavaScript needed to do things on page load that hadn't been updated before. We ended up having to duplicate a lot of code, especially for markup. So if we wanted to render something from the server in PHP and then we wanted to subsequently update on the client later, we had to maintain that markup in 2 different places. And this last point was sort of a big one. Even though Backbone was fairly easy to use, the lack of framework knowledge, maybe it's better phrased like lack of kind of agreed upon patterns amongst everyone, which is very hard to get in a loose framework of Backbone, meant that low-level code was still being written. So what we had tried to get away from ended up just being wrapped inside our view layer in Backbone, which meant that while it sort of looked like we had some structure, we ended up having a lot of the same problems that we always had. And abstraction scalability was a problem. So performance aside, we still had a lot of those issues with structure that we were trying to solve as well. So without a strict framework, developers are sort of free to implement patterns however they would like. And some of them are good and some of them weren't. But it didn't really matter whether they were or not. The fact was there were multiple abstractions that were really written ad hoc as you needed them. Multiple different ways to implement, say, subviews or nested models. And so components written for one part of the site wouldn't necessarily work for another. This wasn't guaranteed. So while there was some sort of kind of general agreed upon structure, at the end of the day, when we were actually writing code and actually building applications, it turned out that a lot of things weren't reusable, weren't shareable. And Backbone was being implemented in very different ways across the site. So now you can kind of see there's like 2 ends of a problem. We're trying to find a way to meet in the middle. One of the first angles of attack that we took on bridging this gap was our template, or templating, our generation of markup. To rewind a little, I said before that when we initially rolled out our MVC framework, we were using kind of pure PHP views for generating that markup. One thing that this made it difficult to do was take that same markup and render it in the client on mobile devices or desktop devices. So we realized that it would be in our best interest to start using templating systems that we could render with multiple languages, and also that would help our client-side team build markup on without necessarily having to know all the ins and outs of the PHP that it was interacting with. So we ended up using Mustache because when we started looking at this, Mustache was fairly proven. It was proven on a lot of platforms that was very easy for us to get up and running with. What we found out about Mustache was that as far as a tool to work with, it was lacking in certain respects. Mustache, for those who don't know, is an extremely simple logicless template system, and that's kind of both, it's really a double-edged sword, that there's not a lot that it can do, and there's really not a lot that it can do. So
we started using it on, rendering it on the server using a pure PHP implementation of the language. And we hit kind of two big performance bottlenecks that I'm going to try to describe. So one of them was loading and managing of partials. Partials are a feature in Mustache where you can reference some other template from within a template. So this example right here is saying, I'm missing two closed curlies there on the closed section. It's saying take some list of elements that are products, and for each one, take that product and render it using a partial. This is kind of a common operation for us because we show a lot of pages that show products in grids and lists. So this is really just a way of encapsulating stuff that gets repeated. Where this gets difficult is that partial doesn't point to anything in particular. You have to tell Mustache that for a partial named product, this is the template that you're going to use to render it. When you have a complex nested template, which is the case on our browse pages, our search pages, our product pages, you can end up with a dozen layers of partials that you have to figure out how to load. So when you're doing this with PHP, you essentially have to go back and forth between PHP and the disk, looking for all of these files, loading them, and weaving them together. Another issue is just context resolution. So what we've got here is a simple template that shows a data element called inner, and then there's a data element called outer, and it shows yet another data element called inner. And what should happen here is the first line here, we should get one rendered, because the data here has inner at kind of the outermost level. But there's this separate block for outer, which contains a different inner. And when Mustache is rendering this content, it has to say, okay, when I'm looking up this value, I'm inside outer, so I'm looking at this data element, so I want to render 2 instead of 1. And the common way that this context resolution is implemented is using a stack, that as you start deciding what you put here, your stack is empty, you check what's at the first level of this nested object that's your data. But once you jump in a level, you push a new element on top of your stack. And because PHP is PHP and not the fastest language and not the fastest with complex data structures, when you get very big data objects that are being traversed by lots of nested sections with lots of partials, this ends up becoming terrifically slow. And it can produce code that is going to be a bit slower than a pure PHP view that's not going back and forth with Mustache. So what we said is not that we want to drop Mustache because Mustache had so many other benefits for scalability, but that we wanted to optimize Mustache. So what we ended up looking into was a C++ implementation of Mustache. So taking kind of all the slow pieces that are in a sense repetitive, that are building strings, reading files, and traversing stacks, and moving them to a compiled language that can kind of handle those things without much of an issue. So this chart is showing our initial rollout of rendering what we call our super browse page, which is if you go to Wayfair and say, show me the beds, you see a grid of products and you see filters on the left side. That's an example of a super browse page. So this is showing the render time in milliseconds over the morning when we deployed using C++ to render these templates. We went from, sometimes close to 60 milliseconds to render that product grid to we've got about like 27 here. So that's kind of a major change of being able to say, here's a tool that gives us opportunities to scale, but we can optimize that tool and let people continue plugging away in a performant fashion.
So Mustache was great on the server, and we realized that we could also share it on the client. So I'm not going to go into too much on this. We used a compiler called Hogan.js, that actually came out of Twitter, I believe, to take these Mustache files that we had on the server that we were already using for server-side render. And if they were being required on our client side, because it was being required via JavaScript, we would pre-compile them at build time to be functions that could be delivered as regular JavaScript modules. And so from the developer perspective, they never had to see these JavaScript modules that were compiled functions that would return HTML markup when given data. But all they had to look at was the nice Mustache templates that were shared in one place. And this meant we could stop duplicating that code. We didn't have to keep duplicating templates. We could write them in one place, and we could be sure that we could access them either from PHP for server-side rendering or from JavaScript if we wanted to update that part of the page after. All right, so that's sort of where we started, what our kind of first attempts at abstraction and performance were. And so now we'll talk a little bit about where we are now, what the present state of the site is, and what we've really been able to do to improve both the abstractions and performance for render. So what does our stack look today? Super simplified. But in terms of rendering, we have our Mustache templates on the server and on the client. And so I think this is kind of an important piece of it. Our Mustache templates kind of pull everything together. Because they're shared, it gives us some cohesion to the client-server divide. And it means that when we think about our view layer, when we think about our rendering in UI, we don't have to think about, I need to do something on the server and then I'll toss it over the fence and the client will handle it. Certainly from a technical level, that's sort of the case. But from a dev perspective, you can start to think of things as a little bit more cohesive. Concerns that really, kind of come together. The rendering can be pulled together from a dev perspective. On the server, PHP, we have our MVC framework. And so that's a big piece of that. And then on the client side, it's not really a language, so it doesn't exactly correspond one-to-one. But we have Tungsten, so I'll talk a little bit about that now. So this was sort of the next iteration of our client-side JavaScript rendering. So we wrote a library here called Tungsten.js. We open sourced it about a year ago, or a little less than a year ago now, so back in April. And so I'll just touch on the structure of it briefly. So Tungsten really has 3 layers. So the first layer is the application logic. This can also be looked at as the dev API. So this is the layer that developers interact with when they're working on Tungsten applications. Then we have our DOM updating layer. And so this takes the place of what we traditionally would have done with jQuery or another DOM manipulation library. We have that layer that handles that itself. And then we have our templates, which is how that markup is going to be described. Still with Mustache, but we use it a little differently now. All right, so the app logic. We actually kept Backbone's API. We were actually fairly happy with it. Not only were we fairly happy with it, they had a lot of code that was already written with Backbone. And while it wasn't perfect, it could be sort of refactored to how we needed with Tungsten. And so that API was familiar to developers. We had code that we wanted to work with. But it had one big problem, and I mentioned it earlier. And that was, it wasn't a strict framework, and it allowed developers to still write DOM manipulation right in their view code. And so it really didn't take care of that performance issue that we had, or that abstraction issue that we had. So with Tungsten, we decided that wasn't going to be a thing anymore. We were going to get rid of that ability. We were going to lock down that API a little bit, reduce the surface area, and make it very clear that DOM manipulation will not work with Tungsten, and there are better ways to do things. We also added a lot more powerful framework features, those features that were missing in Backbone that we found developers were implementing themselves with their own ad hoc abstractions. We implemented for Tungsten overall. And we tried to make it as easy as possible. We looked at what abstractions were currently being used across Storefront, across our engineering teams, and tried to implement those in Tungsten. So one was child views, how we do with nested views. The other was DOM events. While Backbone had some ability to do DOM events, it was still using jQuery under the hood. We realized that was not only a performance issue, but it didn't give us the flexibility we needed to do more interesting events, things like intent events or window level events, or events that traditionally a developer would have pulled in a jQuery plugin that they found to do the job for them. That tended not to, it meant that we sort of had these ad hoc abstractions all over again, but it also had fairly significant performance impacts. So that's the application level. The second layer is the DOM updates. So you might be thinking, if you get rid of the ability to do any DOM updates in your app logic, where does that go? So that moves to our second layer. We actually ripped out the rendering in Tungsten, or any of the kind of the built-in patterns that you'd expect to do rendering in Tungsten, in Backbone. Backbone doesn't force you to use anything, but in general, you're using jQuery to update the DOM. We pulled that out and we replaced it with a virtual DOM library under the hood. So that meant any updates that needed to happen at the DOM layer could be completely abstracted from the developer. And that was a huge value for us, both on the abstraction side of things, because the developer no longer had to worry about the low-level DOM updates, but also from a performance side of things, we now had control over that performance. We could make sure that our implementation for updating the DOM was as fast as possible. So this layer handles taking the output from the template and updating the page. And it does that instead of re-rendering every view every time, which is what maybe a naive implementation of Backbone render would be. It uses a library called Virtual DOM. If you're familiar with React at all, it's a very similar concept. They use the same concept under the hood for updating the DOM. At the end of the day, it could be any DOM updating library. With Virtual DOM, what we do is it maintains a lighter object in memory of what the DOM is supposed to look like. Creates a new version once something is updated in our model, diffs it in memory against the existing lighter object in a way that's a lot faster than if we had to traverse and diff the entire DOM. And then it decides what things need to be done to update the real DOM to correspond with the changes. And it's able to do this in a lot faster way than if we were re-rendering constantly. But we could do any DOM updating library. Google just released a library called Incremental DOM. It's actually a different approach than taking that lighter object in memory. It's able to do more targeted DOM updates on the fly and saves a lot on the memory side of things, on the GC side of things. So that's certainly something that we could implement. We made sure this layer was kind of as decoupled from the rest of the system as possible to enable that. The last piece of Tungsten is the templates. How do we describe our markup? So again, we use Mustache templates. We actually built the framework so that we wouldn't have to use Mustache templates. We could certainly use something else, JSX or handlebars or whatnot, if it made sense. Mustache makes sense for us because of the server-side rendering, as I mentioned earlier. We're able to get a lot of really good performance there. Essentially, a Mustache template, we give it data, and we get something that can render to the DOM. We've hijacked Mustache a bit in various ways over the last several months to try to squeeze as much performance out of it as possible. One example is originally when we used Mustache templates before we used Tungsten at all. The return value of this equation here, data plus template, would give you a string, and you would just use jQuery to put that string and set it to the HTML, the inner HTML of a DOM element, and it would update. We are able to actually, instead of returning just a string, because we have a more intelligent way to update the DOM, we can return an object that can be plugged into our virtual DOM engine and be able to update the DOM that way.
So a step we're taking now is on the server is doing a new iteration on the concept I described before, which is view classes. View classes were our way of encapsulating use-specific logic from controller actions, from models, from other parts of the code. When we first got into their design, I would, I guess, kind of describe our approach as relatively naive. We kind of saw a need to partition it off, but hadn't really foreseen all the different ways that they could be used, how people might attempt to reuse them, and kind of, I guess, unintentionally abuse them. So more or less what the direction we realized we needed to go in was something a lot stricter. So there's kind of a clear sense of the data that you're putting in and the data that you're getting out. In a sense, a view class is a kind of transformer. It's about taking data, and which could be models, could be scalars, could be lists of things, and transforming that into the context used by the Mustache template. So a lot of what we realized we needed was just this stricter contract, so we wouldn't get data being sent to different clients that we wouldn't expect to be there, that people would know what they could look for, and things that you know, seem kind of simple, but when you have a large team, a lot of eyes, a lot of hands working on the code in question, becomes a lot more valuable. And a related thing is just when the output is being used by different clients, which could be server, web browser, mobile applications, then you really do want a stronger contract for what you're going to get on the other side. So as just kind of a quick example of just the syntax we ended up going with, you have some kind of view class that extends a base class, which we call Mustache data. We have inputs that are the class fields, and outputs, which are the class methods. And the way the translation works is through some, you know, simple reflection. The class looks for all of the public methods, evaluates each method, and says, okay, I'm going to put data in the output that has the name, product name, and its value is going to come from the return value of this method. And then there were, you know, other methods mixed in for a sense metadata about this view. So a template name, which is, you know, our path to a Mustache template, which is eventually used to render this. There's some other stuff going on behind the scenes within this base class to enforce certain things, like making sure that you have to define fields if you're going to set them. A feature of PHP is you can't just set arbitrary fields on objects. They will be set. You may not know they're there, and that can be problematic. And also that the outputs of each of these methods has kind of a consistent format, that they're either scalars, lists of scalars, or lists of other Mustache data instances, so that, you know, all the way down the nested data, you have some sense of control of what you're passing around.
All right, so so what's next for framework for how we look at rendering? Just to point out what's next. We're never like completely done on a particular piece, and so it's kind of always looking for, you know, how can we improve something? How can we make lives easier for our developers? How can we build tools that help us improve the experience for our customers? So we just have we wanted to share a few ideas that we're currently working on. So I'll speak to components a little bit from the JS side, and then Adam will fill in on the server side. So moving to Mustache data has given us a lot of opened a lot of new possibilities, and one of them we've started working on the Tungsten side, and that's creating self-contained composable apps in Tungsten. So we call them components, very similar to components in a lot of other frameworks, or web components if you're familiar with those. The idea that a component has kind of all the pieces it needs to render on its own, but it can also be composed into a larger application. And so that's been a valuable abstraction that we've started to work with in our applications and get feedback from our developers in how can we make sure that that's a really easy way to start to build out applications. One of the nice things with Mustache data is that we're able to, on the PHP side, specify the JavaScript Tungsten view and the Tungsten model that's necessary to create these components. So we don't need to keep repeating in multiple places where we're trying to link together different modules. And this has really increased that cohesion between client and server. So it's no longer that we're just putting some jQuery code on a page and putting our PHP on a page and hoping that we happen to find the DOM nodes that we need to add the functionality that we want. We're actually able to have a very predictable and a very clear structure in how we set up our UI components on the page. We're talking a little bit about kind of taking this even further. So like, how could we share validation between client and server in a way that's not like crazy? So we're working on that a little bit right now, and just being smart about the data that we share and trying to reduce any duplication, so that what we send over the wire is exactly the data that we need.
Yeah. One thing I'd add about this notion of components is it's kind of something that I'd say it's fair to say that we borrowed from React. It's something React pushes very strongly, the idea that a part of the page is an independent component that kind of has minimal dependencies on other components. It's, in a sense, kind of an illusion because, as people familiar with presentations on React will know, that the DOM is essentially big global state, and you can abstract away from that, but at the end of the day, it's hard to get away from the very interdependent nature of code that runs in a web browser. But as much as we can, we try to create abstractions to isolate components, to make them more testable, to make it so modifications to one part of the page don't bleed over to something else. Another thing that we're looking into is kind of a language feature of Mustache, which is something called lambdas, which is in addition, which is the ability to, in addition, pass around, scalars, lists, and maps to pass callables, so that when you're resolving a section of data or an individual field, that it amounts to the return value of a function. And this is kind of our current working plan for working around the strongly naive nature of Mustache, that sometimes there is kind of logic that you want to put in, or you do kind of want to call back to something a little more dynamic than the data you're sending in. A big pain point we've had is that Wayfair is an international business. We run in multiple languages, and there really isn't an easy way in Mustache to say, this is a message string, show me the right translation of that based on my current locale. And what we have been doing is in PHP, building up all the strings in their localized format that you may need to render in the template, sending them into the template. This ends up just being relatively confusing because conceptually you want to really think of that message within the template and not as something that's bouncing around, potentially bouncing around multiple layers of views in a complex page. So we're starting to explore using lambdas as a way to kind of work around the logicless nature of Mustache by saying, here's a chunk of data, call back to PHP, call back to JavaScript to resolve this translation on the fly, so people can be a little more nimble with writing this markup. And another thing we're looking into using lambdas for is smoothing out syntax around using Tungsten components within a more complex page.
So that's kind of been the evolution of UI rendering, abstractions and performance improvements here at Wayfair. I wanted to share a few takeaways that we had kind of reflecting on this process and throughout the process. One of them is, abstraction's not a zero-sum game. So when we sort of posed that original kind of hypothesis that as you add more levels of abstractions, things get slower, and as you go lower level on code, things get faster. It turns out that's not really true. Abstraction done right can give you both. And no presentation is complete without a quote from Dexter. So The purpose of abstraction is to create a new semantic level in which one can be absolutely precise. And I think what he means here is, the abstraction isn't just like a 1D line and we move from one side to the other. We're either more abstract or less abstract. An abstraction done right is one that models your application, your software, your API in a way that's trying to, or as accurately as possible, models the system that you're trying to, the problems that you're trying to solve. And we found that, in particular working on Tungsten, what we found is that we could add these layers of abstraction and actually get faster in that process. And that was a really exciting thing to realize. The other one is, the other thing we learned is the problem of rendering. This idea of UI rendering can't be just isolated to just rendering on the client and just rendering on the server. Certainly from an implementation state, that is the case. We look at the technology on the client and we look at how we can implement JavaScript rendering to be faster. We look at server-side rendering and we see how we can improve that. But from a developer perspective, I think you have to think of it as a more holistic problem. What are you dealing with? What is the larger problem you're dealing with? How do you display the page to the user as fast as possible and improve the experience as much as possible? And I think when we've been able to write our abstractions so that it kind of bridges that gap, it's made it a lot easier to reason about our applications at a higher level and stop worrying about these low-level details. We have a phrase in one of our core principles here at Wayfair is that we're never done. And throughout the process of working on Tungsten and working on Mustache templates and working on our MVC framework, it's that this is an iterative process, and that's okay, and that we actually get really good results from working in that fashion. That we'll realize over time, how can we improve things? Either new problems come up, or we find better ways to solve them. And we're really fortunate to have that kind of engineering team to be able to tackle those problems. And so it's been an exciting kind of ongoing process to be able to do that. And finally, performance is a means to an end. Performance is great, but we're not just looking to be the fastest thing out there. At the end of the day, it's about delivering a better user experience. It's about delivering a better customer experience. And closely related to that, it's about delivering a better developer experience so that we can create those new features. And so performance is a large part of that, and it's an often neglected part of it. But it's not the only part of it. We realized, especially when writing Tungsten, that there were some things that we'd have to sacrifice if we wanted to create a better developer experience and better abstractions for scaling out our applications. And that sometimes we might have had to make small sacrifices on performance to get there. Generally, that's not the case. If you're interested in Tungsten a little bit more, we have some really cool benchmarks on where we line up with other frameworks, and it turns out that we fit faster than a lot of the other frameworks that are out there right now, which was exciting to us, but at the end of the day, it wasn't about being fastest. It's about providing that API and that level of abstraction that made sense for rapidly building out applications. Tungsten's on GitHub if you're interested in taking a look. Do you want to speak to the Mustache extension?
Sure. So the C++ extension I was referring to is something that we've been adding on to that was originally developed by a third party. So I'd say the main things that we've been working on it were adding Lambda support, which it didn't have out of the box, and then adding in some kind of custom hooks to make it easy to load big chunks of templates at once. So that link is to the author's repo. If you replace his name with Wayfair, you can look at the kind of Wayfair specific hooks that we've added, but Lambdas have gone upstream.
All right, that's all we have. Any questions?
So how do you scale out when there's a lot of load? I understand that there's rendering happening in the C++ layer. But how do you build for that extra capacity to scale out, or do you scale out when there's a demand?
I'd say the simplest answer is horizontally. PHP is, you know, a PHP process lives and dies just to serve a single request. So your capacity is more or less dictated by what a single box can do. And if you need more capacity, it's usually just a question of adding more application servers and load balancing them correctly.
So you just prepare for the holiday load, or provision?
I'd
It
say.
takes time to build a box, and
Sorry?
it takes time to build a box and do the load balancing and all that, right?
Yeah, but we always hit the holiday peak by about March or April of the following year, so it's not, our traffic isn't all that spiky. So for us, just staying a little bit ahead of the traffic that we have is not a thing that causes any kind of gross efficiency and doesn't put us in the situation of these other internet companies that have different traffic patterns where they really need to sort of scale up and down, or they're waste a lot of money. It's just not the case with other traffic patterns.
Did you guys end up rolling your own MVC framework, or did you use one of the kind of popular PHP ones?
We rolled our own. It's, I'd say, it was written before I got here, but my understanding is it's kind of modeled after micro MVC. The general idea was to keep it really, really lightweight, so it would be easy to navigate errors when they happened, that we would be adding an abstraction, a set of abstractions that would, produce deep stack traces, and to, just have a few moving parts and give us control over it.
Can you talk a little bit more about the virtual DOM and how you're able to kind of do the diff between that and the real DOM efficiently so that you aren't traversing the whole DOM?
Yeah, so we're actually not, so I just wanted to, the library that we use for virtual DOM, it's called virtual DOM. Very confusing in discussions. But virtual DOM, so we didn't write that. It's been around for a while. It's fairly popular. It's used by some other frameworks as well. But the general concept of virtual DOM diffing, we're not actually diffing the virtual DOM tree against the real DOM tree. We're maintaining in memory what we think the current, what the current tree is, or should be if everything went according to plan. And then we diff against that. So then, based on that, we can figure out we get a virtual DOM will give you a patch object, or it gives itself a patch object that it then uses to go and make the operations to update the DOM. So diffs the tree, patch operation, updates. Yeah.
So you mentioned, you mentioned DOM and JavaScript. What are you doing with your components to handle CSS and sort of component include CSS and component definition?
That's an interesting, it's like a hot topic today, like over the last year in particular. So right now we maintain that separately. So we haven't fundamentally changed the way we build things out. We have a pretty robust CSS framework, maybe is the word, but system for handling CSS across multiple brands, but also across different pages and different sites. We use Sass to manage a lot of that. What we are looking at, and maybe could have been on a future slide, on the future slide, is pulling that into our components a little more tightly, kind of bringing that cohesion to the CSS as well. Because right now it is sort of like CSS lives over here, and then we do all the JavaScript and DOM stuff here. And hopefully things line up, and it usually does, and it's usually not a lot of work, but it would be nice to be able to say, hey, this is my product block component, and I know it's going to be styled correctly, and I know it's going to have the right markup and have the right functionality all together and all contained. Components will definitely give us that ability. One of the challenges, of course, with CSS is that it's not scoped or encapsulated. So you have any kind of scoping you would give it would be a very leaky abstraction, just dealing with that. There are ways around that, but it's definitely kind of one of those mismatches in abstractions that it's hard to get right.
I have a question about with using Mustache and everything. Did you showed that graph where it went from 60 milliseconds to 20 milliseconds, went from PHP to C++, right? How does that compare to any page that was actually just rendered like PHP markup?
I can only speak anecdotally about that because after a certain point we weren't running an identical page side by side. So I think when we did the initial rollout, the Mustache render time was maybe actually a little slower than the pre-existing pure PHP. We're still paying a little bit of a penalty for going to disk to fetch all of the partials, to parse them, to string them together. Because one of the benefits of pure PHP is that it'll get handled by opcode cache, so in a sense it can be extremely fast. But we more or less said that we're willing to take a little bit of a penalty on rendering markup because it's going to give us the opportunity to do so many other things in the future. One kind of common truth about website performance is that a lot of the time is not spent on the server, it's spent in the client. So when you're looking at the where something is slow, there's typically a lot more headroom in rendering the page, doing repaints, parsing and executing JavaScript. So if you can get yourself in a better position to optimize that part of the experience, the net gain will probably be much bigger.
And just speak to the JavaScript side of that. One of the big wins that we got from Tungsten is we're still certainly, running a framework to handle, we're running a lot of JavaScript to handle interaction. Sure, the site could be fast if we took all the JavaScript off, but it's not a great experience because and also it wouldn't actually be a faster experience going from page to page, for example, because you would make round trips that you don't need to make. One of the big wins is we can actually do, we can be very optimistic on the initial page load because we know that the templates are shared from client and server, that Tungsten doesn't have to do any, it doesn't do any DOM diffing or anything on first page load. It doesn't have to do any rendering at all. And so actually the abstraction there is sort of where we got the win there, because before, if you were writing a different module that needed to, there were places where you might use a JavaScript function to like format something on the page or format currency or rearrange something. And so if you go to sites that still use that, you'll see kind of a glitchy experience on first page load where you see the kind of page load and then something change. Not only is that sort of a jarring experience for the end user, but it's also a performance hit because now JavaScript's executing on the DOM, and you're probably doing read-write, probably alternating rewrites, which is a problem too. So you're probably repainting, and so there are a lot of issues there. And if the user starts scrolling during that process, like, forget about it because you're just going to drop frames like crazy. So once we're able to get into a state from the UI side with our Mustache templates, we could say, hey, we know for sure that our page is going to be rendered how we want it to be rendered, and we don't actually have to do any DOM manipulation after the fact. And in a lot of cases, we can do that now. We can say, hey, don't even bother, checking the DOM and updating something. So those are that's actually a really big optimization that we were able to get with sharing those templates.
Anyone else?
Thanks.
All right, thank you.